Alright, two students are pulling on a box initially at rest with a mass of 13.5 kilograms. So initially at rest with a mass of 13.5 kilograms on a frictionless surface, so there's no friction. Student 1 is applying a force of 16.5 newtons to the left. So, drawing my free body diagram, I have 16.5 newtons to the left, while student 2 is applying a force of 3.7 newtons. That's 3.7 newtons to the right. Find the velocity of the box after 6 seconds. So if we look at all the stuff that we're given mass is 13.5 kilograms. We're given the initial velocity is 0 because it's initially at rest. We're given time is 6 seconds, and we're asked to find the final velocity. Now, if you look at all of the equations that we have, the kinematics equations, in order to find final velocity, we're going to have to know the acceleration. Well, we don't know the acceleration, so in order to find the acceleration, we're given the mass and we're given forces. So we need to find the net force. So we're going to have to kind of work backwards. We find the net force to find the acceleration, then we use the acceleration to find the final velocity. So if you look over here, our net force, we have 16.5 in the left direction, so that's a negative 16.5 newtons, and you have 3.7 in the positive direction. So our net force is (16.5) negative plus 3.7 positive is a negative 12.8. So our net force is a negative 12.8 newtons. So that's what we put here. Negative 12.8 newtons. Now, we know that our mass is 13.5 and we know our net force. So F equals m times a. To find acceleration, we divide both sides by m. So that gives me F divided by m equals a. So my acceleration is my negative 12.8 newtons divided by my mass of 13.5 kilograms. Alright, so I do my negative 12.8 divided by 13.5 gives me an acceleration of negative 0.95. Oh, we'll do 48. So acceleration is a negative 0.948 meters per second squared. Okay, so we found our net force, we found our acceleration. So now we're going to look at our equations for velocity. We know that we have this equation of acceleration equals Vf minus Vi divided by t. Well, I know Vf, I know Vi. Sorry, I do not know Vf, that's what I'm looking for. Okay, I do know Vi, it's 0 because it's at rest, and I know time is 6 seconds, and I know acceleration. So I'm going to solve for Vf by multiplying both sides by t. The t's cancel, and I multiply by t. So my final velocity is my acceleration times my time. So my final velocity is 0.948 meters per second squared, and that's negative, times my time, which is 6 seconds. So I take 0.948 negative times 6 equals my final velocity is a negative 5. Well, since that's only one significant figure. We're going to round that up to a -6. So VF equals -6 meters per second. In this case, that -6 means he's going 6 meters per second in the negative direction.